Let's look at alkene bromination. We take ethene reacting with bromine and giving a product of 1,2-dibromoethane. In this case, bromine is the electrophile reacting with this pi bond, addition into the pi bond, and before the reaction, bromine is actually a red solution, and after the reaction it will be a clear solution because 1,2-dibromo has no color. Now that's something to know. Now how the reaction takes place: in first step, the pi bond is actually when it's closer near to the bromine, the first bromine will be delta plus and the other bromine will be delta minus. The reason is it just changes the polarity because of the approach of the pi bond. As a result, what happens, the pi bond is broken, but it will keep the bromine as bromonium, and it's called the cyclic bromonium for the plus, and the bromide, the delta minus Br, will be released as bromide with the pair of electrons, right? So that's the first step. And in the second step, what happens, we still have the cyclic bromonium and the positive charge actually rolling around the two carbons and the bromine, and the bromide released is sitting next to. Now this will attack as a nucleophile either of the carbon because it's symmetric and opens up the C to Br bond. Now what happened, this Br came from the bottom, this Br pushed onto the top. So that's how the anti-addition took place. Now this can be drawn in a different way too, because ethene is a flat molecule. So you can draw it, the Br can come from the bottom, and then you will make the cyclic bromonium towards the lower side of the molecule, and then you can get attacked by the cyclic bromonium will be attacked by the Br released bromide, and that has to come from the top, right? Either carbon is fine, and then you will get the same product. So it's a different way of drawing it. So practice couple of ways. So either you're given the 3D structure or the... Here we have cis-butene. The bromine molecule is, let's say, approaching from the bottom of the molecule, and the pi bond approaches and creates a delta plus on the bromine, and the attack goes on and creating the cyclic bromonium on the pi bond, right? So cis-butene can make the cyclic bromonium either bottom of the molecule or top of the molecule. So now the Br delta minus will be released as the bromide, and it will attack either of the carbon because it's symmetric, and you will have that bromine is sitting on top of their carbon, right? And so if you think about the 3D, right, so the Br should be on top, the other Br should be on the bottom. So now what we have is 2,3-dibromobutane, and in this compound you can also think about the three-dimensional structure and actually give the R and S configurations accordingly, right? So we'll do one, and if necessary you can try that. So bromine is 1, CBr is 2, and the CH3 is the 3 priority. Hydrogen is 4th, we don't care. So 1 to the 2 to the 3 rotation will give you R, right? You can do the same thing for the other one. So you will end up with R for that one too. Stop the video and try. And then just think, because bromine came from the bottom of the molecule, you get the R to the R. And if the molecule attacked by the top by the bromine, that would be S to the S. So this is possible for cis-butene to have an enantiomer pair, and that would be a racemic mixture. Okay, all right. So the other thing, something important to see, if you have something like this cyclic compound, let's say our electrophile from Cl and Br. In this case, Br will be the electrophile. The reason is electronegativity difference. Cl gets more negative. So therefore, the pi bond will only attack to the bromine, and you will make a cyclic bromonium again. So just try to complete. Thanks.